Good day, everyone. Once again, this is Maestro Eitan of Science 8. Welcome to our physics class of the first quarter. Here we are now in our week number 3. What are the factors affecting potential and kinetic energy? For our quote of the day, I can do all things through Christ, my God, who strengthens me. From the Bible book of Philippians 4:13. Before we proceed with our lesson, let's have a quick recap and review of the things that you have discussed in your previous grade. The work continues. The work done by a constant force is defined as the distance moved multiplied by the component of the force in the direction of displacement. Therefore, work is equal to force times displacement, wherein displacement answered the questions how far out of place an object is from the initial to the final position. It is different from the distance, wherein, on the other hand, distance refers to how much ground an object has covered. We're talking about the measurement. Yung layo ng isa't isa, that is the distance. Yung pagbabago sa position, that is the displacement. At nag-apply ka ng force, therefore, you are talking about unbalanced force. If it is unbalanced force, there is an external net force na nakialam sa system. Therefore, there is movement and there is motion. Therefore, there is work. Because work is equal to force times the displacement. And talking about work, we're going to correlate it into energy, wherein energy is defined as the ability to do work. If there is an energy, you are able to do something. If you are having an energy, you are able to do work. Therefore, we're talking about the two major forms of energy and the factors affecting these forms. First is the kinetic energy. When we talk about kinetic energy in relation to work, when work is being done, there is the presence of kinetic energy. That's why it is the energy in motion. Lahat ng bagay na gumagalaw. Sabi nga, ito ay nagmula sa Greek word na kinetikos, meaning moving, or there is movement, or there is motion. Therefore, it is kinetic energy, yung mga bagay na gumagalaw, which is different from potential energy. When we talk about potential energy, it is present when the work is waiting to be done. Ibig sabihin, it is in balance form. Meaning, when we talk about balance force in our previous lesson, wherein the equilibrium is zero and equal yung opposite forces. Meaning, the object is at rest. The object is not moving. Therefore, it is potential energy. We're talking about being stored energy. It is at rest. It is in zero. It is in equilibrium. And also, potential energy is said to be the energy of position. We're going to talk about the forms of potential energy later on. Looking at this illustration, the laptop is on the table, wherein there is a gravitational force pulling the table and a normal force supporting the laptop weight. Therefore, it is potential energy. In chemistry, in the chemicals, there are stored chemical bonding. So therefore, it is potential energy. But in this case, if you apply another form of energy, for example, thermal energy, nag-apply ka ng heat, nag-apply ka ng apoy, therefore, nagre-react ito sa chemical. Therefore, there is movement of chemicals. Then, ibig sabihin, a potential energy can be turned into kinetic energy, and also kinetic energy can be turned also to potential energy and vice versa. Let's move forward. All right, talking about the potential energy, these are the two major forms. We have the elastic potential energy and the gravitational potential energy. From the word elastic, we're talking about being flexibility, nababanat, nahihila, nai-stretch. So it is also a stored energy as a result of the formation of an elastic object, for example, a rubber band. It is said to be stored, elastic, based on its elasticity or flexibility or ability to be stretch. It is equal to the work done to stretch a spring, which depends upon the spring constant as well as the distance stretch. So, na-stretch natin yon pero may hangganan ng pag-stretch natin sa rubber band. So, minsan napuputol natin because it is the limit of the flexibility of the band or the rubber band. So, elastic potential energy. There is a stored energy which is potential. It is different from gravitational potential energy. We're going to relate the gravitational force or the force of gravity, wherein it is also a stored energy in an object as the result of its vertical position or height. So, kanina sinabi natin potential energy is the energy of position. Depende kung saan nakaposition ang object. If it is, for example, the laptop on the table, it is said to be gravitational potential energy because the laptop is pulled down by gravitational energy and it is being supported by a surface of the table which is a normal force. Therefore, it is still at rest. Therefore, it is said to be gravitational potential energy. Right. Looking at this bow and arrow, if you're going to stretch this bow, it is still elastic potential energy. Pero kapag pinakawalan mo na yung arrow in a bow and hit the dartboard, so we're talking about another form of energy. Let's move forward. Looking at this illustration, let's look first in the bow and arrow. Like what I've said, it's exhibiting potential energy. Meron tong potential energy or the stored energy which is elastic potential energy. There is elasticity, ability to be stretched of this object. Still, it is being stored. Nag-apply ka lang ng force nung hinila mo. Yes, it is kinetic. Pero naging potential ito once it is already in position. So therefore, it is elastic potential energy. Then when you release the arrow and hit the dartboard or the target, you are now exhibiting kinetic energy. Meanwhile, when the arrow is in the air, also it can be turned once again into potential energy. Sa paanong paraan? So sa air resistance, still the arrow is being pulled down by the gravitational force. Meaning, when it is in position in the air, there is a potential gravitational energy. And when it hit the target, once again, it is potential energy. So ibig sabihin, an object can be turned from potential to kinetic energy and kinetic to potential energy. Looking at this illustration, the hammer, why it is said to be potential energy? Ganong pupukpukin mo na yung pako gamit ang martilyo. Because looking at our examples in our previous lesson, in our balance and unbalanced forces, if you are holding something, you are holding the hammer, therefore you are using support force or what you call the normal force. The normal force is said to be at rest. You are not still. Hindi mo pa pinupukpok yung pako dito. Still hawak mo pa lamang. Therefore, it is said to be potential energy. It is just an stored energy in position. Then when you release the force and start to hammer the nail, therefore, it is already kinetic energy or the energy in motion. And when there is a contact with a hammer and nail, it is another form of energy which is mechanical energy. Wherein mechanical energy is the combination of the kinetic plus the potential energy. So that's it. So we're talking about the different forces plus the different output wherein you can have an output of work using the energy, wherein it's said to be the energy is the ability to do work. Let's proceed. Looking at this, we're now going to answer the questions, what are the factors affecting potential and kinetic energy? For potential energy, here we have the three major factors: the mass, the acceleration due to gravity, and the height or the position of an object in a gravitational potential energy. We're talking about the mgh, wherein mass is equal to m, where the unit is kilogram, and the constant for the acceleration due to gravity is 9.8 meter per second squared. Sometimes we are using 9.9 up to 10 meter per second squared if it is rounded up. But of course, for our standardization, we're going to use 9.8 meter per second squared for the acceleration due to gravity. And also, another factor affecting potential energy is the height or the position of an object. So it's said to be positioned if there is a gravitational potential energy. For example, the flagpole. The flag in raised in a flagpole. It is in position up there, then therefore it is gravitational potential energy being stretched with a tension force, right? And gravitational force doon naman sa lower part. So still it is stored energy. And we're talking about the height, which is, the unit is meters. Meanwhile, in kinetic energy, the factors affecting it are the mass and velocity. Mass, which is m, the unit is kilogram, and velocity is equal to v, wherein it is measured in meter per second. So therefore, velocity is the rate of the movement with direction. So the unit used is meter per second. All right, let's proceed. Let us focus first in our potential energy. How to find potential energy? Of course, we need to prove our content or the theory that we are talking about later on, to prove it and make it a fact. So potential energy is equal to mass times the acceleration due to gravity times and multiplied to its height. All right, so we have that, wherein mass is equal to kilogram and acceleration to gravity, which is represented by letter G, and the unit is meter per second squared, which is 9.8, and the height in meters. So this is the formula that we're going to use in potential energy. This is the equation. PE is equal to M multiplied to G multiplied to H. But of course, if we're ought to answer and solve for the mass, the acceleration due to gravity, and the height, here we have the formulas. We just need to divide potential energy to the acceleration due to gravity multiplied to height if we're going to be asked to find out what will be the mass is. Then also, we're going to ask for the acceleration due to gravity. The same thing, you're going to divide the potential energy, the given potential PE, and of course, divide it into the product of the mass times the height. And later on, if you're going to be required to answer for the height, you're going to also divide the PE divided by the product of the mass times the acceleration due to gravity, which is 9.8 meter per second squared, which is constant. Pag sinabi natin constant, hindi na yung nagbabago. Ibig sabihin, that is standard, which is 9.8 meter per second for the acceleration due to gravity. So here we have the formulas that we're going to use in order to find out the potential energy and sa components related to it. How about in kinetic energy and the work energy principle? So we're going to relate now what is the relationship between the work done and the energy used in order to do some work. If we write the acceleration in terms of the velocity and the distance, we find that the work done here is work net force is equal to 1/2 mv squared of the velocity of the final velocity minus the half of the product of mv squared mass times velocity squared of the initial velocity. Looking at this illustration, ito yung ating initial velocity. nung hindi pa lumalayo yung ating bus. At yung ating final velocity nung umandar na ang ating bus. So, ibig sabihin, we're talking about displacement from the initial to the final position. Kasi nga, nagkaroon ng pagbabago ng position. How far an object is out of place in its position. So, yan. Then, of course, hindi gagalaw tong object if there is no application of force. So, meaning, merong unbalanced force. And also, there is a friction force that makes an object move and stop on its position. So, we're talking about displacement. So, ibig sabihin, may force, may displacement. So, we're talking about work, which is work, sabi natin kanina, work is equal to F times D, which is force times the displacement. Ibig sabihin, dito sa illustration, nakita natin na may work na nagawa. And of course, if there is ability to do work, there is also energy. Wherein, if we're going to subtract the initial to the final position, like this formula, we're going to define kinetic energy as 2. Kinetic energy is equal to 1/2 mass times velocity squared. So that's it. Or simply, KE is equal to mv squared divided by 2. Or KE is equal to mv squared all over 2, which is the same as we divided into half of it. So ito yung ating gagamiting formula in solving the kinetic energy. Therefore, we can relate now na talagang ang energy is related to work done. And of course, if the work is being done or nagaganap, kinetic energy is observable because there is movement. There is action na nangyayari. Therefore, there is kinetic energy. And also, we can transform one form of energy into another form. From kinetic to potential, from potential to kinetic energy. Now that we knew the factors affecting them, here we have the conservation of energy. The energy before and the energy after. Let's say here we have the ball in position. It is said to be gravitational potential energy because we have the height of an object. Kapag nahulog yung bola mula sa kanyang position dito sa taas, so nahuhulog at nalalaglag, therefore it is moving. Therefore, there is kinetic energy. Alright. Then kapag ito'y bumagsak na, titigil to because of friction force. Because there is an attraction between two objects and there is a presence of gravitational force that makes the object retain on its position and it is pulled downward. So makikita natin dito, from potential energy, naging kinetic energy, bumagsak, nanatili sa position because of friction force at gravitational force. Therefore, again, it is potential energy. So dito, potential energy is equal to mass times the acceleration due to gravity times the height. Ano ang bigat ng bola? Ano ang taas ng kanyang position? Then, i-multiply mo rin ito sa constant na 9.8 meter per second, which is the acceleration due to gravity. Ibig sabihin, yung bilis ng kanyang pagbagsak. Yun yung ating acceleration due to gravity. Sabi nga natin, acceleration determines the velocity of an object. So, ibig sabihin, gaano kabilis bumagsak yung bola sa sahig, that is acceleration due to gravity, in regards to its height at saka sa kanyang bigat, which is the mass. Then we're talking about the potential energy there. Then, nung nahulog na, gumagawa na ngayon ng movement. Therefore, yung kinetic energy, ma-measure mo na yung bigat niya sa kayang velocity. Gaano naman kabilis ito meter per second squared. So, gaano kabilis bumagsak ngayon yung bola. So, you're going to have the kinetic energy. At nung bumagsak na at nandun na sa sahig, again, the potential energy is 0. Kinetic energy naman ang ating mineasure dito sa baba. Kung nasa taas, ang mineasure natin is the potential energy wherein the kinetic is 0 because the object is at rest. Kasi nga, nandun sa position pa lamang yung bola at hindi pa gumagalaw. Nung bumagsak na, mineasure na natin ang kinetic energy. At nung nasa sahig na, again, zero na ngayon ang potential energy natin. So, ganun din. So, ibig sabihin, dito sa ating meaning, the beginning energy is all potential energy. Then, the mass on both sides, dito sa ating potential kinetic energy, tells you that the final velocity doesn't depend upon the mass. So, hindi nakadepende sa bigat ng object ang kanyang bilis ng pagbagsak. So, makikita rin natin dito, may another tayong natutunan. So, hindi pala nakadepende sa bigat or gaan ng object ang bilis ng pagbagsak ng isang object. And also, the final energy is all kinetic energy. Yes, kasi nga, magkakaroon ng movement. Because there will be a motion. There will be a moving of an object. Therefore, it is kinetic energy. So, ibig sabihin, nagkakaroon ng relationship ang ating kinetic and potential energy. And also, since work and kinetic energy can be equated, sabi nga natin, it is related to each other, work and energy to work, they must have the same units. Kinetic energy is measured in joules because work is measured in Newton meter or joules. From an English physicist known as James Prescott Joule, who established that the various forms of energy like mechanical energy and heat are basically the same and can be changed one into another. So ito si James Prescott Joule. Sa kanya dinerive ang units ng work and energy, which is joules or Newton meter. The application of the distance and the force applied. Alright. So, pinakita rito sa illustration natin dito that there is a relationship between work and energy. Ayan. May distance, may application ng force, may displacement, then therefore, there is ability to do work, there is energy. Alright. Here are some of the forms of energy. In potential energy, we can categorize chemical energy as potential because it is a stored energy in bands. Chemical bonding is stored energy. Also, elastic, stored energy due to tension. Sabi natin, tension force is the ability to be stretched of an object. Nuclear energy is also a stored energy in the nucleus of an atom as either positive or negative charges. Gravitational energy is stored energy due to position above the ground. Based on its position, the energy in position is gravitational potential energy. On the other hand, we're talking about kinetic energy. Kinetic energies are the thermal energy because thermal or heat energy is the moving particles. It is moving, actually, the heat energy. And mechanical energy, energy found in objects in motion. So everything that is mechanics, there are movements. For example, in chewing something, chewing your food using your teeth, or what you call mastication, it is mechanical energy. Therefore, it is kinetic energy. Then kapag nilunok mo na yung pagkain, sinamahan na ng chemical, therefore, matatransform siya into chemical energy, into PE, potential naman yun. Okay, looking back into other forms of kinetic energy, we also have electrical kinetic energy, the movement of electrons. Yung movement ng electrons sa saksakan kapag pinalag-in mo ito sa female socket, so sa ating source ng electricity, magpo-flow ang electron sa wire. And that is the movement of electrons, and that is electrical energy. The sound wave. The sound wave is reaching us. The sound or the wave from one position can be heard in our position because it is moving. Therefore, it is said to be kinetic energy, the wave energy. And also the electromagnetic waves. All the waves in the EM spectrum moves. Lahat ng waves ay gumagalaw. Pwedeng longitudinal, yung iba is somehow zigzag. So here we have the EM waves as the kinetic energy. Parang ito yon, right? So everything that is moving is kinetic energy, and everything that is being stored and in position is said to be potential energy. So we're looking forward that you have learned something in the content of this week number 3, the factors affecting potential and kinetic energy. We're going to move on to the computation parts and some exercises. We're going to use the aggressive format in solving the potential and kinetic energy problems. Of course, G stands for our given, and R is the required or what is being asked in the problem. And we need to write down the equation or the formula to be used. And S for our solution. And letter A is for our final answer. Here we have the first problem. You throw a ball with a mass of 2.1 kilogram. The ball leaves your hand at 30 meters per second. The ball has blank energy. Calculate it. The very first thing that we need to do is to analyze the problem. Thinking of that you are holding a ball. Meron kang daladalang bola na may bigat na 2.1 and you throw it sa bilis na 30 meters per second. Meaning, from being stored in your hands, there is a potential energy. You release it using and applying a force. Therefore, the ball moves. And the ball has kinetic energy right now. So that the things that we're going to calculate is our kinetic energy. But here, we need to write out our given. First is our mass, which is equivalent to 2.1 kilogram. Then velocity, which is 30 meter per second. And our required right now is KE or kinetic energy. And the equations that we're going to use is KE is equal to the product of mass times velocity squared divided by 2 or 1/2 mv squared. Okay, then the solution. KE or kinetic energy is equal to the mass. What is our mass? All you need to do is to substitute the given to the equation or to the formula that we're going to employ right now, which is 2.1 kilogram for our mass. Multiply it to our velocity, which is 30 meter per second, and we need to square that. And all in all, we're going to divide it by 2. Okay. Then, let's make use of this. Okay. Since we're looking for KE, right? KE is equal to 2.1 kilogram. That's it. And you need to multiply it to velocity. The very first thing that you need to do is to multiply the velocity to itself. It doesn't mean that you're going to multiply 30 times 2. That is wrong. So all we need to do is 30 times 2. That is squaring an integer or a number. So meaning we have 30 times 30 is equal to 900. Yes, exactly. That's correct. 900. Since we squared, we also squared the meter. Meter squared. And also the second squared. Since all are being squared, then divided by 2. So that's it. Then it is equal to 2.1 times 900. So we're going to multiply the two variables. 2.1 times 900 is equal to 1,890. Then copy the unit, which is kilogram. Okay. Then meter squared. And second squared. Okay. Then divide it by 2. So that's it. 1,890 kilogram meter squared second squared divided by 2 is 945. All right. 945. And of course, all you need to do is to copy the units. Kilogram, then meter squared, second squared. Okay. Looking here, we can now identify that this unit is just the same with work. Since work, sabi natin before, work is equal to force times distance or displacement. Since force is equal to Newton, then distance is equal to meter, work is equal to, this time it is equal to Nm, or what you call as joule. Alright. So joule ang ating gagamitin, Nm or joules. So meaning, we have the N. According to our previous lesson, N or Newton is equivalent to 1 Newton is equal to 1 kilogram meter per second squared. So that's it. 1 Newton is equal to 1 kilogram meter per second squared times M. Alright? So minultiply pa natin siya ng M. So we are multiplying same units. Therefore, we can now get the same units here as it is. Alright? So meaning, kilogram meter squared or second squared, the same with the units of work, which is equivalent also to joules. Therefore, we can now say that kinetic energy for our final answer is, kinetic energy right now is 945 joules. So that's it. It is just the same units with work and energy. All right. So that's it. We're going to look at in our first problem. Okay. So that is for kinetic energy. Let's proceed with the next. Next problem here is, there is a bell at the top of a tower that is 45-meter high. The bell is 45-meter high and it weighs 19 kilograms. The bell has blank energy. Calculate it. Again, let us analyze the problem. Sa taas ng tower ay merong bell na 19 kilogram ang bigat. At ang tower mula sa ground ay may taas na 45 meter. So, ibig sabihin, hindi naman gumagalaw yung bell at nasa taas lamang in position. Therefore, the bell has potential energy, specifically gravitational potential energy, and we need to calculate it. Okay, let's proceed. What is our given, or what are our givens? We have, how about 45 meter? So that is the height. So h is equal to 45 meter. And the bell weighs 19 kilograms. So we're talking about the mass, which is 19 kilogram. And of course, since we're talking about gravitational potential energy, there is a constant for acceleration due to gravity, which is 9.8 meter per second squared. Okay. So kompleto na ating given. Then what is our required? Since we're looking for potential energy, then PE is our required. All right. And the equation or the formula to be used. PE is equal to mgh, or simply that we're going to get the product of the mass, then acceleration due to gravity, then times it or multiply it to the height. Then the solution. All you need to do is to substitute the given so to our equation. PE is equal to what is our mass, which is 19 kilogram. Okay, 19 kilogram. And our acceleration due to gravity is standard. When we say standards, it is constant. Hindi na yun nagbabago, which is 9.8 meter per second squared. Okay. Then our height is 45 meter. That's it. So we're going to get the product. And our answer right now is, we're just going to multiply it all. 19 times 9.8 times 45 for the height is equal to 8,379. 8,379. Then copy the unit, which is kilogram. Okay. Then bring down m. Since we are going to multiply the same units, so we're going to add the exponent of it. So meter plus meter is equal meter squared. Then second squared. That's it. Then our final answer is PE is equal to 8,379 joules. All right. So that is our answer. So for us to write it down dito, so we have 8,379. Para makita natin, that is exponential yung ating numbers dito. Meter squared and also second squared, or simply 8,379 joules. So that is correct. Okay, all in all, here we have our problems for kinetic and potential energy. Hoping that you have learned in our lesson. Thank you and God bless.